So let's say you're given this diagram illustrating the projectile motion of a ball. Could you tell me what is the time of flight of the ball? If not, let's look at it together. So we can start off by identifying a key characteristic about the diagram. So if we draw it again here, I want you to notice something about the landing and the origin. You should notice that the Y position in these two spots are the same. Introduce that at the start, the Y position is equal to 0, and at the end, the Y position is equal to 0. This would be useful to calculate the total time of flight. Now we can use this concept to solve. If we use the Y motion equation here, and then we plug in our values, we plug in Y equals 0 and Y initial is also equal to 0, just like we found. Plug in our initial velocity equal to 10 meters per second sine 30, and it's sine 30 because if you remember from trig, sine theta is equal to opposite over hypotenuse. If you look at the triangle here, and the vector we're looking to use is Vy, so if you look at the diagram, that's the opposite vector. So if we plug all this information in, we get this expression here. Notice that our unknown value is t, so that's what we're solving for. Evaluate the term on the left and get 5 meters per second, and then evaluate the term on the right and get negative 4.9. We can isolate for t by multiplying both sides by 1 over t, and then we can bring 5 to the other side. We can multiply through by 1 over negative 4.9 to isolate for t, which if we do this, it leaves us with this expression here, and then we can just evaluate this term. So negative 5 divided by negative 4 is 1.25, and then meters per second divided by meters per second squared is just seconds. So we get our final answer here for the time equal to 1.25 seconds. So this represents the total time the ball is in the air. So if we look at our diagram here, the time from the initial to the final point is the time we just found.